Hi, everybody. Welcome to Virtual Chemistry. And I thought after about 2 weeks now of getting our toes wet, I wanted to really lay out the clear expectations so that you guys know exactly how to be successful in virtual learning for me. So everything begins with Canvas. And I post everything that we do. Let me get the pointer here. I post everything within modules. This module I created just for this situation. And I post everything by week, and I have the dates here. So this was the tasks that were due week 1, last week. If we move forward to the current week that we're in, these two tasks were due on March 25th. And you'll notice in my screenshot here, I just have the date that they're due. You guys would also have the time on those dates that they're due. So for example, B1, your due date would have been 8:17 a.m. on the 25th, because that's when your class begins. And then notice task 3 for this week is due Friday, and again, Friday at the start of each of your particular classes of chemistry. So that's how things are organized within Canvas. Now, how to take attendance, I'm going to show you this same week, week 2, in the calendar view. So here is the 23rd, that was a Monday, and then we have our Wednesday class and our Friday class. So this is a snippet from a student who's in B3. I know that because of this, the due date time is when third hour begins. So in order to be marked present for the 23rd, you would need to submit these tasks by the start of the class on the 25th. To be marked present for the 23rd. To be marked present for Wednesday, the 25th, you would need to submit this task by this time on the 27th. So you would have, like, in theory, the actual class period and any homework downtime to complete those tasks. However, keep in mind, I don't anticipate that these tasks taking anywhere near the 85 minutes that they would that a normal class would be. So this should be much less time that you're using for chemistry. So that's how attendance is taken. Now if we look at the upcoming week, week 3, here's our dates. There are 2 tasks that are due by the start of class on the 31st. If those are finished, then your attendance would be present for the 27th. That would be the Friday before. So this is a Tuesday, this is a Thursday. And then what Mr. Frisky and I have started doing is, starting on the 31st and the 2nd that week, we are going to host a virtual classroom every B-day during your regularly scheduled class time. And it's to kind of touch base. It's to go over and preview the tasks that you guys will need to do for that particular class period. And it's to do sample problems to make sure that you guys are successful in moving forward. And I think it'll make doing the tasks a lot easier and faster if you attend these virtual sessions. I can't require you to, because I can't go to your houses and be like, click here, join the class, but I highly recommend doing it. So if you would click on this link, I'll show you what that would take you to. That would take you to this Google Drawing, and you can read all about it, but these are the virtual classroom links for each section I have of chemistry. And you can attend any of them if one time isn't convenient for you. And then if you can't attend any of them, I will be posting a link of what happened in that class, and you'll just see more and more of those links as we progress through the weeks. So I think that's a great resource to go to, and this will always be found every week in modules. You'll see this same link. Now, if nothing works or you attended the class sessions but you had some other questions as you're working, if you signed up for text alerts, you can always text me through that app, through your phone. You can always G-chat or video chat me, because if you think about it, in class, you would simply raise your hand, I'd come over and I'd help you, and you'd be able to move on. And so these are really quick ways to just get a quick answer to your questions, and so you're not just sitting there getting frustrated. I can help. You just have to reach out to me. So back to our new unit on something called the mole. The mole. You're probably thinking, what the heck's a mole? So I'm going to walk you through and narrate two little snippets of videos on what the mole is to just give you a little bit of sense of things, and then you're ready to delve into the rest of the task for this upcoming week. So here we go. All right. So what's a mole? A mole is just a really, really big number. And chemists work all the time in moles. And so a mole is just a specific quantity. So in life, we might ask for a dozen eggs, or a pair of socks means two, or a ream of paper means 500 sheets. Same thing as a mole. It's just a number. It's a six with 23 zeros after it. It's huge. So you could have a mole of eggs or socks or a mole of paper, but usually chemists work with quantities of atoms or molecules, which are really, really tiny. So we need a number that can quantify how tiny these are because we're working with such massive quantities of atoms. It's six with 23 zeros after it. That's a mole. And so to kind of give you a sense of how big a mole is, if we had a mole of marbles and we put it around the Earth's surface, it would cover to a depth of 3.5 kilometers. A mole is a massive number, and chemists use this number for this quantity because atoms are so, so tiny. So let me show one more snippet of video. So exactly how much does a mole weigh? So if we compare, it just depends how big each atom is. So you can imagine there's the same number of atoms in a mole of gold atoms and a mole of hydrogen, but gold has a lot bigger atoms. Hydrogen atoms are tiny, much smaller than gold. And so if you would weigh a mole of gold and a mole of hydrogen, even though they're the same quantity, they'd weigh more. Just like a dozen eggs weighs more than a dozen grains of rice. So that's why we use the concept of a mole. It's a big, big number, and we can make it much more tangible if we use the concept of that, just like a dozen eggs. So what the mole allows us to do in chemistry is to take something macroscopic, such as grams of a substance in a beaker, and we're able to use the conversion factors of a mole to know how many atoms of that substance are in that beaker, which is pretty cool if you ask me. So it's just a bridge between the macroscopic world and the microscopic world. If we look at our handy dandy periodic table, you'll notice that a mole of sodium contains this many atoms. That's a lot. But so does a mole of copper. It contains the same amount of atoms. The difference being the mole of sodium weighs 23 grams, whereas the mole of copper weighs 63. So we're going to use a lot of math on this periodic table and a lot of these atomic masses in order to work in the quantity, the unit, and counting feature of a mole. That's what this unit is about. So before you finish, I want you to go back into this assignment and complete the quick poll that's also linked there. And then you have one more task to complete before the start of your class on the 31st, and then you'd be all set. And then please make every effort if you can to attend our virtual classrooms every B-Day. Will help you navigate all the other tasks that you need to complete for that day. And I think you're going to enjoy this unit. It's a lot of fun. And please, 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 this is my workstation. Reach out to me. I am ready to help you guys so we can continue to move forward in this virtual world. Good luck. Thanks for listening.